Hello. In the last two of these videos, we have discussed so-called monovariate data. Monovariate data is generated whenever we perform a set of experiments and take one measurement from each experiment. However, there are countless experiments we could perform where we might take two or even more measurements. A statistician, when presented with this sort of data, might ask themselves if there is any relationship between the measurements that were taken. To put this on a more concrete footing, let's introduce a dataset that comes built in with R, the so-called CARS dataset. The data in this dataset is contained in a data frame, and we can view part of it by using the command shown here. Notice that the CARS dataset contains 50 rows, so I'm using the head command so that R only shows me the first 6 lines of data. Seeing these 6 lines of data is enough, as all I want to do is see what the various columns of data represent. Notice that the data frame has 2 columns. The first column is the speed of the cars in miles per hour, and the second column is the stopping distance in feet. Incidentally, in case you are worried that these are extremely slow cars, given that they're travelling at a whopping 4 miles per hour, you are right to worry. This data was collected in the 1920s. Anyway, we might suppose that the stopping distance of a car is affected by its speed of travel. To test this hypothesis, we might produce a graph like the one shown here. This graph has the car's speed on the x-axis and the stopping distance on the y-axis. You can see here that the stopping distance generally increases as the car travels faster. However, we cannot draw a straight line with the general form y equals mx plus c through this data, which means that we cannot say that the only thing that affects the car's stopping distance is the speed it is travelling, which makes a lot of sense. A car with much better brakes will have a stopping distance that is shorter. The stopping distance will also be affected by the reaction speed of the car's driver, and so on. It is important to note that even when there is perfect correlation between two variables, that is not sufficient evidence to say that one thing causes another. As with the monovariate analyses, we make many assumptions when we do this form of analysis. It is massively important to remember that the correlations we have talked about in this video never imply causation. It is, however, always interesting to identify when variables are correlated and what variables are not correlated. There are many mathematical techniques for automating this form of analysis, but it is hard to beat drawing a graph like the one shown on this slide and looking at the relationship between the two data sets yourself. In other words, what I am saying is, you should always draw a graph whenever you are investigating correlation. Thanks for your attention.